Hi, good morning, everyone. I hope you all can see my screen well. My name is Hunter Huber. I'm a technical sales representative here at OGI. Today, we will be going over a little bit of critical spare parts and preventive maintenance, specifically for the TERI heaters. Before we dive into that too deeply, we'll go over a little bit about OGI. So if you do not know, OGI stands for Oil, Gas, and Industrial Process Equipment. We design, manufacture, sell, and service TERI brand water heaters and QuickWater brand direct contact water heaters. Along with that, we also do process controls. We have a ULC panel shop. OGI serves the natural gas, food and beverage, concrete, commercial laundry, pharmaceutical, commercial car wash, and manufacturing industries. And along with that, we also do some government agencies as well. We are proud to be a certified women-owned business. And OGI has been in business for 31 years. We are headquartered here in Sand Springs, Oklahoma. And with that, I'll go over and give it to Jim Winzo, who will go over some startup service and maintenance.
Thanks, Hunter. So one of the things that we want to do is we're going to go over basically preventative maintenance and some critical spare parts. One of the things that's important is preventative maintenance is a means of ensuring that the equipment is readiness for operation and finding potential problems early to avoid any untimely breakdowns or outages. This presentation outlines what OGI believes is to be the best or the most important list of inspections for the equipment to analyze this equipment to help our clients meet the annual demands for a TERI brand heater. As well, we've included a list of critical spare parts that are important to keep on hand to also ensure that readiness. So today's we will actually review the following. In a preventative maintenance program, we're going to look at visual inspections, component and instrumentation inspections, burner safety limit verification, burner combustion analysis, and heater operation review. And then finally, we'll actually get into kind of a list of critical spare parts. First thing that's important is to actually do a physical inspection to understand the visual appearance of the heater, conducting a walk around in our terms to provide an overview of an as-found condition of the heater, inspecting for atmospheric corrosion, on the paint, on the saddles, on end plates, on piping, inspecting for the foundations and the skids and the anchoring of these heaters to those foundations, looking for cracking, whether the bolts are tight, and is the skid properly supported. Next is the heater alignment and the levelness of the heater. Are the foundations displaced due to frost heaving or sinking, or is the process coiled to field piping? Does it have any apparent stress on the process coil connections caused by field piping, or maybe the settling of the heater and its foundation? And then we're going to do some visual inspections for damage of the heater's insulation and jacketing, making sure that the condition of the jacket caulking is good. It's not cracked. If it is, obviously repair it. And then checking the alignment of the flame arrestor and the stack to ensure that they're plumb. Next, we're going to actually look at the stack itself and confirm that, is it normal, or in this case, as you can see, we have a discolored stack identifying something wrong with potentially the combustion or maybe the system in itself. We'll also inspect the heater shell for leaks, and also we want to know about the glycol level. Is it appropriate, and is it showing in the expansion tank? As far as the heater shell leaks, we're going to look at the shell flanges. We're going to look at instrument connections that are in the shell, and then the next step we're going to look at is the grounding. Is the heater properly grounded, and are those connections still valid? We're going to then look at, after we've gone through a general visual walkthrough, we're going to actually take a more concentrated look at the components and instrumentations associated with the heater. So we're going to start with a flame arrestor. Here we're going to confirm that the heater, the element is not plugged, which is a common fault of causing the combustion to create problems with the combustion process of the heater. So in this case, we're going to look for dirt, possibly cottonwood, even bird nests. We've seen bird nests and mice nests actually developing in a flame arrestor. In this case, we went actually back below dry, high pressure air through the flame arrestor in the opposite direction of the normal airflow. And if you do use water or some kind of high pressure water wash, we encourage you to blow that out again with dry air. It ensures that the element, the small openings within that element, are free. The next thing we want to take a look at is to remove the actual hammerhead flange off the end of the stack and actually look through the combustion chamber to make sure that it's free of any kind of debris. Could also be discoloration caused by direct flame impingement of the main burner. We want to make sure that those items are don't exist, and if they do, we need to make some modifications or changes to the setup of the burner, and obviously clean out the debris that may be in the fire tube. Next, we want to take a look at the burner. We want to confirm that the mixer and the orifice and the nozzle are clean, that there's no soot or buildup on that, and obviously if they're dirty, they'll actually create a poor combustion because they're not going to be entraining air properly with the fuel that we're trying to burn in the fire tube. And then obviously the next step is to take a look at the pilot. Here we're going to inspect the ignition rod. Is the pilot nozzle clean, and is again the orifice clean on the pilot? We want to make sure that if there's a sensing rod, that it is also clean and properly aligned, and that the ignition wires and the ground wires are tight and well connected to the pilot assembly. And then from that, if there's any issues that we see, we're going to go ahead and make those repairs. Additionally, we're going to actually ensure that the Bezos thermocouple connections are properly secured to both the Bezo and obviously the head of the pilot. The next step that we're going to take is we're going to review the pilot to burner alignment. When assessing this, we want to ensure that all pilot tubing and burner piping is inside the flame arrestor are tight when we're finished. But in doing so, we want to ensure that that pilot is properly aligned with the head of the burner to avoid any potential disruption or instability caused by the main burner on the pilot. So it's kind of an important part, since we're trying to maintain that pilot stability, and that seems to be that's the heart of the operation of the unit. The next step we want to look at is actually the condition of the gauges. Are they readable? Are they accurate? And those can properly be looked at on a case-by-case basis. But ensuring that all of these things are in good shape is very important. Excuse me. From a component aspect, ensuring that the regulation system, the natural gas pressure regulating systems are properly working. In this case, we'll actually remove the heads of the regulators and inspect the discs and the seat to make sure that they're clean and they're not damaged. We'll also blow down the fuel gas supply strainer to make sure that we free up any potential debris that was captured. And then from there, we'll actually go into and reset all the regulators to ensure that they're set at the proper pressure set points based on the flow diagram. And then, of course, obviously, with taking everything apart, we want to confirm that from a leak inspection standpoint, that all the piping and tubing in that gas train are free of any potential leaks. And then In doing so, we also want to confirm the operation of block valves and needle valves, and actually doing a soak test on all the packing glands to ensure that we don't have any leaks on those cases. If there is any leaks or repair required, then we'll conduct as much as we can. Or in some cases, somebody may have a kit that would repair that potential damage. In general terms on that component inspection, we also want to take a look at the condition of the glycol that's in the bath. So in this case, the first step we want to do is take a look at the latest glycol report to confirm that the glycol samples have been drawn and that the bath chemicals are or have been corrected. In this case, at the time, let's say a year ago, that samples were taken, we want to make sure that those there's a documented path that says that, okay, we found something that was low and that it was treated to bring that pH or that inhibitor level at the right level, and that the glycol was made back to a good form. In this case, after we've reviewed that, we want to go ahead and pull a sample and have it actually analyzed for the typical characteristics that glycol should be performing to. And that can be conducted, as noted here, by the customer's glycol water supplier. Typically, whoever supplied that water glycol has the best understanding of what is the glycol water composition and characteristics that ensures that chemical makeup is correct for the particular inhibitors that are in that glycol media. And also it's a good indication of them looking for trace metals on a historical basis. You can actually kind of judge where your glycol level, your glycol concentrations and its performance is running, as long as you're finding minimal trace metals in any sample that you're taking. Next, what we want to do is we want to look at the control systems that are actually supporting the heater. The first, obviously, one of the more popular ones that are used for a TERI brand heater is a pneumatic control system. So with that, we want to take a look at the temperature and the safety control valves. If they are Chemray type valves, they typically come with an oil level that's actually in the head of the valve to make sure that the stem of that valve is properly lubricated through the life. Sometimes that oil will run out, or you have a leaky O-ring, it needs to be replaced. In that case, the oil level needs to be checked just to ensure that it's properly protected. Next, we want to blow down the pneumatic tubing to and from the field temperature controller. And what that does is it just ensures that it's free of any debris. We also want to inspect that the pneumatic temperature controllers. We want to ensure that that they're installed properly, so that they're not potentially collecting water onto the top where the control set point is adjusted. We want to make sure that control adjustment is free to move. That will also tell us an indication of if it's not free to move, that potentially that the mechanism internally is somehow questionable, and it needs to be maintained and possibly replaced. And we also want to make sure that the inlet filter is free of any debris. The supply filter is actually just a cartridge that can be removed, again, cleaned up and blown down. And then the final thing that we want to look at associated with the pneumatic systems is to ensure that the bezo operation is working properly, actually testing the millivolt signal coming off of that thermocouple going to the bezo, and making sure that it's receiving it and actually effectively supporting proper operation in the event that it loses signal, that it shuts down, and the fact that there is a flame signal, that it actually operates correctly. For the electronic control systems, We want to actually open up all the electronics housings and take a look to make sure that the terminations are good, that we're not seeing any moisture or potential corrosion inside of these instruments. That includes control panels. If we're seeing condensation, it may be warranted to actually, request desiccant bags or locate some desiccant bags to put inside of those control panels to keep them dry. We also want to inspect the panel fuses for control panels of any type to ensure that we have the right size fuse, or that a fuse hasn't somehow been changed out of just needing to keep something running for some reason, but making sure that the right fuse is installed, as well as that the fuses are good. So we're going to check continuity on those fuses to make sure that they're in good shape. Additionally, in electronic control systems, we want to take a look and verify that the control voltages are correct. Especially in the case of like UPS systems or solar power systems, we want to make sure that each of those components that support for example, a solar system or a UPS system, that the output voltages from the batteries are correct, that the solar panel charge levels are good. In the case of the solar panel, we obviously want to make sure that the panel is clean, because if it's not clean, or if it's covered with debris or even snow, it will not charge the battery properly. Some obvious things like making sure that the panel is facing a southern sky, and that we're going to then again measure the voltage out of that panel, which should be between 14 and 17 volts DC, depending on the size of the panel. The battery charger operation is, again, we're going to make sure that the output out of that battery charger, if it's a solar powered system, that the solar panel would have to be installed. But if it's an AC supported UPS system, again, we'd have to make sure that AC power is provided to that. But either way, we want to make sure that the output voltage is between 12 and 24, or 12 and 14 volts DC, depending on the system. Finally, we have the battery itself, and this is one of those things where the battery, depending on what its output's doing or what its purpose is, most of the time we're looking at a 12-volt battery that's going to have a range of about 11.5 to 13.5 volts DC. But one of the things that's critically important is that battery be tested annually under a load. So basically performing the load test on the battery to ensure that it has some integrity to support your operation throughout the year. The hard thing about that is batteries that you would use for this system do have a shelf life. So in this case, having them on the shelf, like in a spare part situation, doesn't hold true very much for you. In this case, you want to test it early to find a problem early, so it can be ordered and you've got the freshest battery possible. So in some cases, some people have invested in a battery load tester. Other people have just taken it down to like an auto parts store and have them actually load test your battery. So to each his own there. In the electronic controls area, we have some electronic temperature controllers and shutdowns. We want to verify that those are actually set up properly, that they're temperature elements that are actually supplying the temperatures, indication or measured temperature to these controllers are reading accurately, and also that finally that the temperature controller set points are correct. And if they're not, then we need to understand, if there's been a change, why. And then there could be just someone trying to, you might say, take care of an issue by making an adjustment versus, it could be a telltale for another problem if a set point has been changed. The next thing that we're going to actually get into is actually evaluating the burner safeties. Now that this process includes walking through the operation of each instrument to ensure the functionality and appropriate control response to changing conditions is actually correct, and that basically repeating the functional acceptance test conducted by OGI at our facility. Note that in this case, the safety and the temperature control logic is very similar for both pneumatic and electronic natural draft burners. So essentially, whatever general or burner specific shutdowns we may have, they are similar as far as the way that they work for either of those two systems. For each type of control, the shutdown of the main burner and the pilot, when applicable, will be verified for each of the instruments. So in this case, the general safety limits that we'll be reviewing will actually shut down the main burner shutdown valves. We'll close the burner temperature control valves, shut down the burner, obviously, because there's no gas flow to it. And then we'll actually shut down the pilot assembly and the pilot with those general shutdowns. And those general safeties include both the low water level switch and the high temperature switches. Now, this is the minimum of that. Obviously, there could be other things such as, from a general safety, again, this is not burner specific, but general heater safeties that could also include a high process temperature alarm that is either at the outlet of the heater or it could be at the outlet of the regulating system. Burner specific conditions, these are again things specific to the burner. They also include the loss of the pilot, obviously the BASO safeguard, the Kimray pilot guard. It could be a flame rod or UV scanner that's used to actually sense that. And then we have the added limits that could also be burner specific. And again, just to point out that anything that could potentially shut down the burner would potentially, depending on the condition or the particular installation, could also shut down the pilot. So I think that's very important to remember. In this case, we have low and high main burner gas pressure. We also have high process temperature or high stack temperature. Again, these are specific to specific conditions that we have. As far as the high stack temperature, we have a stack guard, or it could be that's for a pneumatic system, or it could be electronic, like in a Wattlow high temperature limit controller, or even a Phoenix Contact electronic temperature limiter. The next thing we want to take a look at is, so we've gone through and we've reviewed the functionality of these systems, of the safety systems that are a part of the burner. We've ensured that the controls and the instrumentation of the heater are in good shape, and we've gone through our visual inspections and our glycol inspections. So essentially, at this point, now we're looking at the control that could be a part of the burner management system or a relighter system. In this case, we want to confirm that the pilot, the main burner solenoid valves are working properly, and that the main burner temperature control valve is operating the way it should based on different things. So in the event that there's a request or a call for heat, we want to make sure that we have spark, that the pilot ignition is working properly, that we're actually sensing flame. And then in the event of a loss of flame, that on a BMS or a relighter system, that the flame is relit when it's applicable. In some cases, a client has requested that it's not, like for a power burner, it would not be. And that in the event that there is a flame loss, or in this case, in a relighter attempt, it's not relit, that there's a lockout based on flame loss. We also want to make sure about the functionality of the temperature control valve. In this case, we want to verify that that control valve will close when the main burner safety limits aren't satisfied. So when there's a burner specific or a general safety shutdown, that valve is also closing. We also want to make sure that valve opens and closes when there's a call for heat from a temperature controller, and that the on transition speed to that avoids any potential stack draft issues, any potential problems with the pilot, blowing the pilot out, or that transition isn't too quick that it actually causes main burner instability. After we've gone through that and we've got a decent pilot operation in a main flame that's working properly, we want to go ahead and evaluate the burner combustion and make sure that the performance of that burner is in good shape. So at this point, what we like to do is we like to allow the main burner to run for about 5 to 10 minutes and then actually conduct a stack emissions after the stack draft has been properly established. So here, as you can see, that we're going to take a look at any excess O2, the CO concentration, stack temperature. We're going to compare those to the ambient temperature and the bath temperature. And if available, we're going to actually measure the fuel flow rate. And then from that, we'll be able to define a performance, as you can see on the left there, of the burner efficiency, the combustion efficiency relative to stack temperature and excess O2. Now, those aren't the only indicators. We can get into that in another time. But essentially what we want to do is, if we're outside of what would be considered acceptable for the ambient temperature that we're operating at, adjustments will be made to bring the burner into good operation. From there, we'll actually make sure, then verify that we have good pilot stability during the transition phases, and if necessary, we'll have to make adjustments on the main burner cycle, cycling on and off using the bath temperature or process temperature controller. And we'll just want to make sure that, again, we have good pilot stability after we've made those adjustments, and then if there are any additional adjustments need to be made to combustion to ensure that everything is working properly, that would be done then. With that, I'd like to move into spare parts. In this case, I think it's important to know that heater readiness is not only defined by the preventive maintenance performed on the heater, but also ensuring that you have critical spare parts on hand to replace worn or damaged parts found during the PM inspection can actually help to improve the readiness of the heater. Spare parts requirements will vary based on the size of the heater, the type of the heater, and also the ignition system and monitoring systems, and of course the gas train. One thing that you're going to see throughout this portion of the presentation is that if there's a critical spare that we feel is important, we've identified that with a parent, asterisk parent type indication at the end of each of those. And we understand that that spare parts inventories will vary based on the purpose of the heater and the process, whether it's a fuel gas heater for power generation or gas compression, or maybe it's just a gate station heater, something that actually just supports dew point operation under a regulating system. It can also be dependent on the number of similar types or styles of heaters that you have in your gas distribution system, the distance or proximity to a centralized parts inventory, or in some cases it just could be, company preference or policy that says, we will or we will not maintain, these spare parts. What's important is that, what's important is to have the parts on hand so that if a problem does occur with the heater component, instrument, or control valve, you're able to make the repairs and get the equipment back online quickly, saving your company time by avoiding additional delays and expense. So realizing that it's an issue to maintain spare parts, but at the same time it's kind of a risk assessment that has to be done for the particular heater location. In this case, what we're going to do is we're going to take the next few minutes and talk about different spare parts at different levels. In this case, from the base parts levels that are most common to the heaters to those that are more specific to unique burner or heater applications. So in this case, we're going to start with the base parts. So the most common part that you're going to find on any heater is going to be the regulator. In this case, one of the easiest things to maintain as a spare part is the disc, and it's probably one of the more used or potential fail points of a regulator is the plug assembly that's on that regulator. There are regulator kits that are available that also include the plug, but also include the diaphragm. I think though most natural gas heaters utilize the same regulator style, alternate regulators are commonly used for four-strap burners applications requiring different spare parts. So one of the advantages, as we talked about in the previous slide, was that inventories that you have on most common parts make sense. But in some cases, when you have a unique operation of, let's say, a four-strap burner or a larger capacity burner where you have a unique regulator that's not in your common stable of parts, it may be worthwhile to have that in your inventory. Other parts that are also considered common for your every heater would be your pressure gauges and temperature gauges, and most of the time you can maintain those inventories because they're fairly commonly located at your local instrument supplier. Next, I want to talk about our control systems. In this case, we're going to start with the pneumatic control systems. The most common use of the most common controls that we see that are necessary, as you can see by the asterisks located, is the temperature controllers. In this case, we're showing a Kimray. Pilot guards, there's two different approaches that are taken on pilot evaluation or flame sensing, and that would be the pilot guard, the Kimray pilot guard shown in the lower right-hand side, or the Bezo pilot guard valve. In this case, in looking at the operation of a heater, the pilot is obviously the one operation that is the most critical. I mean, I realize that there's things associated with the bath and regulation and these other things, but if your pilot isn't working or your pilot isn't reliably being sensed, then your heater literally is down. So it's important, I think, to maintain those parts like the Bezo valve, like the thermocouple, like the Kimray pilot guard systems in inventory, because under critical need, that's when you're going to have them. And if they're not available, then literally your heater will be down. So in the case of a pneumatic control system, those pilot and those pneumatic controllers are extremely critical. The next thing we want to talk about are just push button lighters. The ignition rod is probably the most sensitive piece of that puzzle, and it also kind of covers a number of different applications you're going to see here. But the ignition rod is probably the one area that I think would be important to have. The batteries used are going to vary depending on the particular push button system that you have, and those are typically available at your local discount store. Now what I want to do is get into some comparison between relighter systems and BMS systems as far as spare parts are concerned. And you're going to find that there's actually some similarities, some commonality between the two. But at the same time, and some of these things will cross over between the two systems. So first of all, we want to talk about is the solenoid valves. In this case, we have on the relighter system, there's a burner control solenoid, and it's a single solenoid system. On the BMS systems, typically there's a pilot solenoid that enables and disables a pilot based on safety conditions that aren't necessarily satisfied, or maybe a loss of flame. And then, of course, the main burner solenoid. And there's a lot of similarities between the main burner solenoid and the relighter's burner control solenoid, based on the fact of the type of system that we're talking about, whether it's pneumatic or electric, as far as how the BMS is being employed. The next is ignition and sensing. There's that igniter rod again. And in some cases where we're going to a burner management system where we're employing this on a power burner, or maybe a more elaborate natural draft heater or burner, you'll actually have a UV scanner where it's important to have both the sensing tube, the ultraviolet sensing tube, or the shutter assembly on hand as a spare part. Those are typically the ones that are actually operating the most. And in that case, if either one of them are failing, the heater will be shut down. Ignition module for the relighter system or a BMS flame module. No matter what system that you have, for relighters or BMS systems, these flame modules are extremely important. Not having one on hand, and obviously if you have multiple systems out there, one or two of those on the shelf really will pay dividends. But either way, those flame modules are what sense the flame and what actually controls the BMS or relighters systems. So essentially, it's the brain of the operation. Everything else is literally relays and solenoids. So having those as part of your spare parts inventory is extremely important. The next is obviously if you, this is where things start to separate a little bit. If you have a more elaborate or complex electronic control system, you might have, like in this case, a Honeywell burner management system. It's important to have that controller on your shelf, as well as the flame amplifier, and as we're showing here, the ignition transformer. Those are the common parts that are going to potentially fail based on any voltage surges, or just in time the ignition transformer gets weak for the work that it has to do to relight the burner when there's a call for heat or whatever there may be. The next thing we want to talk about, and this again specific to the burner management systems or the higher end electronic systems, it's there's temperature control relays like the one shown on the left, or maybe a high temperature shutdown, which could either be the Wattlow or the control relay shown to the left. And there's also the temperature elements, which is one of those things that we inspected during the preventative maintenance side. But in the event that there's something found where maybe we have a failed element on or a bad RTD, it needs to be replaced. Having that on the shelf would be helpful. Some common parts that are common to both the relighter and the BMS system, that includes fuses, logic relays, communication cable, and again, here we are back to the battery of both of these systems. Now, the reason that I've got that battery flashing or pulsing is the importance of knowing that it's important to realize again that battery will not last over the course of multiple years on the shelf. It's best to have a plan that's a part of your PM system to test the load capacity of the battery throughout the year. In this case, like before you start your heating season, for example, make sure that battery is in good operating condition and that it can carry a load through the winter. Last thing you want is for that battery to fail in the middle of winter and now your system is down whenever the sun goes down. So, or you lose 120 volt power. So anyway, I think it's important to know that, okay, it is critical, but yet it's not something that you're going to be able to put on your shelf and rely on from today until, for 2 or 3 years. You'll have to continue to do your testing. Next thing I want to walk into here for spare parts are PLC and electronic systems. These are the more complex systems that have more unique parts specific to them. Many times that these parts include power supplies and control transformers. These are PLC processors, PLC logic modules, indicator lights, panel selector switches, and HMIs. Now, I think what's important to remember here is, okay, so we made a list of things and we say that they're important, but many times what happens is that these types of systems are typically associated with a customer who has inventory on these types of control systems already part of their station. So in those cases where they don't, they either have multiple heaters that already are utilizing these types of controls. So if you don't have it, at your station, you might have it somewhere else. But what we would recommend, and we've seen it actually firsthand, where somebody didn't, they had a unique actuator or a part that failed on their equipment, and they actually had it on the shelf because of the particular need. In many cases, it's because of what we had listed earlier. It was a power generation station, and obviously they were going to lose many dollars per hour by not having that heater operational. So they were able to change it out because they had the part on hand. Something else that's associated with the electronic systems are specialized pressure switches, which we saw in the previous slide, as well as valve actuators, which I just discussed, manual valve seals and seat kits, and of course safety and control valve repair kits. Could be O-rings and diaphragms. All of these things, again, are kind of a judgment call. In many cases, they're driven by an approved manufacturer's list that a particular vendor or a particular customer may have on their site. In support of all this, the spare parts and the preventative maintenance, OGI does offer a startup and commissioning support for our customers, and we are more than happy to work with you. And as we're saying here, we have well-trained, experienced technicians that understand combustion, that understand controls and the heaters that they're working on. They also understand a lot about the particular systems that our heaters support. So at any time that you're looking for support on maintenance or startup, we can help you out there. Thank you for coming to the presentation and the webinar. And again, if you have any questions, please feel free to reach out and contact us. Have a good day.